Hey there, math fans. I'm going to try to quickly talk about how to solve 2x2 and 3x3 problems, systems of equations for my pre-calculus class. Now, if you go on and take math, at our school, it's Math 208, which is about linear algebra. You'll learn about matrices. You'll learn how to write this as a matrix, how to manipulate the matrix, and that's just an organized way to do what we're about to do. The goal in general, when you're solving systems, is to reduce the number of variables. So the whole goal is to go from 3 variables to 2 variables by combining to 1 variable. So I realize that some students don't have that idea in their head, even though they've been finding intersections for a long time. If you found the intersection of lines, if you found the intersection of other things, you've already been doing this. That's the goal. So before we do that, I need to talk about how to go from 2 variables to 1 variable. So let's just do a quick example. Maybe I'll come over here and just make up some numbers. Okay, let's do this. Let's say we have 3x plus y, x minus y. Let's make this 12. Let's make this 6. I'm just throwing some numbers in, so I don't know what this answer is. If I said solve this system, we'll come back to the problem that's up there. The goal is to combine. It's not to set equal. I never say the word set equal because over the years I've seen too many students say, well, first set equal, and then they write 6 equals 12. Or they write this equals this. Or they set both equal to 0 and then set them equal to each other. They just start kind of randomly setting them equal. That's not the goal. The goal is to come up with a number here and here that are the same, and a number here that here are the same that work in both. That's the goal. So at the end of this question, we're going to completely check. And that's why I have my calculator open in the corner. There's 2 ways to combine. The one way that always works is what I call the take it and shove it method. Solve for one of the variables in one of the equations. And if you want just to say, just tell me the steps, then this is the way you would do it. You would say, step 1, solve for one variable in one of the equations, and then shove it into the other. That always will work. It doesn't take any expertise. As long as we can solve for one variable in one and can shove it in the other. That's it. That's the technique. That's how you go from 2 variables to 1. And then you can solve the resulting 1 variable equation. And then at that point, that number should work everywhere. Sometimes students say, I don't know where to plug it in when I get there. The answer is you plug it in everywhere to find the other variable. So that's this substitution is what it would be called, is what we just did, to reduce the number of variables. The other way you can do it is you can add and subtract side by side. And that's just a clever way to substitute. And the idea is if you have 2 things that are equal, so if you have, like I always say, if you have 2 equals 2 and you have 3 equals 3 and you add the sides, are they still equal? Yes. But we're doing it in a situation where we have a variable. So if we add these side by side, what happens? Well, this becomes 4x because it's 3x plus x. And this becomes 0. So this only makes sense, the side by side adding, if you actually cancel something, which I set it up perfectly to happen here. So I added side by side, I got 18. That's another way to accomplish the same thing. So our 2 techniques are to substitute or to add or subtract side by side if they accomplish our goal. And the goal is to reduce the number of variables. Okay, if you kept solving here, this would give you 18 over 4, which is 9 over 2. If you kept solving here, it's the same thing. X minus 12 plus 3x is 6. You would get 4x equals 18. You get x is 9 over 2. Then you could plug that in anywhere and get y. So a little bit of fraction work maybe here. Y is going to be 12 minus 27 over 2. I did 3 times 9, which is negative 3 halves. The one comment I always make to students is there are a lot of places you can make mistakes. So it's very important that you have your calculator out and you check. So you do 3 times whatever your x is, 9 halves. So what am I doing right now? I am going to plug into all of this and make sure it's 12. I'm going to go back to the source of the problem. So I'm doing 3 times 9 halves. And this really doesn't take that long. It's just be part of your routine. If I was taking a test, I would always do this. And I get 12. Boom. It's very satisfying. And then you also need to check the other one. You can't just check the first one. It's very common to get one of them right but not the other. So let's do the x. So I'm going to do 9 halves minus negative 3 halves. So just plus 3 halves. And now I'm going to hope it's 6. And if it's 6, I can go on my merry way. I know I'm right. That's it. So I find a lot of people don't have that built into their routine, that you should know you're right, and that the two techniques to reduce the number of variables is to add equations side by side if you happen to get rid of a variable, or to substitute. Okay, I'm going to erase that, and let's go to this problem. So here's the problem, same idea. I want to reduce the number of variables either by substituting or adding side by side. So pick two of the equations and start to try to put them together. So to me, when I look at it, it looks like I can add these side by side. But I want to comment, it took cleverness. I had to see that the C's cancel. But I saw that if I add 1 to 2, and I'll say something about this, I'm going to get 3a, that plus that. I'm going to get b minus 3a, so minus 2b. And then I'm going to get 0, which is the whole reason I added them side by side. If you add equations and it doesn't get rid of a variable, that was a waste of time. So that's 1 and 2 put together. Notice we got rid of a variable. If you say, I didn't see that, I just wanted you to give me a method that always works, then the method that always works is pick one of your equations, whatever it is, solve for one of the variables, whichever one you want to solve for. Let's say you added c to the other side, and then you got c by itself. This is the tried and true method, and then shove that into the other equations. So if you take equation 1, solve for c, and then replace this c and replace this c, how many variables will you have? 2. That is the technique. Take it and shove it. Okay, so I'm just going to use since I see that the c cancels, I'm going to do it again with 1 plus 3. And in linear algebra, you formalize this. That's actually called a row reduction. So we're going to do 2a. So I did a plus a. B plus b is 2b. The whole reason I did it is because I saw these were going to cancel, and I get 5 and negative 1, that's 4. That's the goal. So the goal is to go from 3 variables and 3 equations. This is essentially the goal of all solving. Reduce it down to 1 variable, and then you'll have it. Now at that point I have 2 variables, so I'm sort of back to the drawing board. I can either solve for one of the variables, like I could solve for a and substitute in, or I could add or subtract side by side. And in this case, they've set it up perfectly so you can add and subtract side by side. Do you see that? So I'm going to add them. So I get 5a plus 0 equals 17. And we've done it. We're down to 1 variable. We solve that. We get a is 17 over 5. All right, I had a brief interruption from family there, so I'll if my video had a skip, that's what happened. Okay, so now we've solved, and we have a. That's it. You can see how fast it was, but it's not always that fast because the numbers were kind of nice here. This was a homework question. But again, we added side by side because it looked a little easier, but you could have also done substitution. We got a. We went from 3 variables to 2, 2 variables to 1, and we got it. At this point, if you're asking, where do I plug it in? The answer is you plug that number in everywhere. It should work everywhere. But since we usually just go back to the 2 equations and try to solve for b. So let's pick whichever one of those is easier. To me, the second equation looks easier. In fact, you could divide everything by 2 and you get this. So b is equal to 2 minus a. So you can plug that in. b is equal to 2 minus 17 fifths. So that's 10 fifths, that's negative 7 fifths. And at this point, you could stop and check that those 2 numbers work in both of these. But let's just go all the way back to c. So now I can plug it into any one of those equations, and I can find c. In particular, maybe I'll plug it into this one. I think C ends up being A plus B minus 5. So C is A plus B minus 5. So that's 10/5. So 2 minus 5, -3. That's it. And again, I would not enter this until I checked all three equations. So I'm going to do A plus B minus C, and it better be 5. So let's do it. A plus B plus -7/5. And it is nice when you're putting your calculator, like I probably should just put minus, right? So get in the habit of saying minus is just a plus. Okay, and then lastly, minus C, minus -3, so it's going to be +3. 5, success. You don't see it, I'll make it a little bigger. Now we try the next one. The next one needs to be 8. So 2 times, and I'm just plugging into these. This is our goal. You always go back to that. So 2 times A, 2 times 17/5, minus 3 times -7/5, plus C, which was -3. 8. Success, we're almost there. Come on. And I should tell you that when I was working with a student and I did exactly this and I had it wrong. But because I had checked, we're like, okay, why is that one wrong? We went back and we were just able to fix that one spot rather than just throwing up our hands and saying, this guy's terrible. That's still probably true, but okay, 17/5 plus B is -7/5 minus 3. If it's -1, we're done. Oh, yeah. Okay, that's it. I hope that helps.